Hello everyone, I'm Abhishek, and in this video I'll talk about third and final part of integration by substitution. And in this video my primary focus will be on this four standard integrals, that is integration of tan x, integration of cot x, integration of secant x, and integration of cosecant x with respect to x, and how to integrate sine to the power mx into cos to the power nx for various conditions of m and n. Now let's start with the first integral, that is integration of tan x dx equals to minus of log mod cos x plus c or log of mod secant x plus c. Now let's see the proof of this integral. Here tan x integration tan x dx equals to I. Now let's find out the integration of tan x dx. So let us consider this one as I. Now this integral can be written as integration of sine x by cos x dx. Now we can assume that cos x equals to z. So from this we can write minus sine x dx equals to dz if we differentiate both the sides. So therefore minus sine x dx, now I can be written as minus of minus sine x dx by cos x. Now this minus sine x dx will be dz. So therefore we can write this is minus dz by z, which will be equals to minus of log mod z plus c. Now we will replace the value of z. The value of z is cos x. So it will be minus log mod cos x plus c. Now for the second part of this integral, that is we have to prove this one as a log of mod secant x. Now there is a minus 1 multiplied with log. So this minus will be multiplied with this cos x. So we can write log of mod cos x whole to the power minus 1. Now this one is not cos inverse x. So this is cos x whole to the power minus 1. Now cos x whole to the power minus 1 is equals to 1 by cos x. Now this 1 by cos x will be secant x. Hence we got the result. That is integration of tan x dx will be minus log mod cos x plus c or log of secant x plus c. Now let's see the second. The second one is integration of cot x dx will be equals to log of mod sin x plus c or minus of log mod cosecant x plus c. Now here also we can do cot x as cos x by sin x as we know. Then we can assume sin x as z. Now this proof is similar to the first proof. Now let's move to the third integral, that is integration of secant x dx will be equals to log of mod secant x plus tan x plus c, or we can write log of mod tan pi by 4 plus x by 2 plus c. Now let us see the proof of the first part, that is log of mod secant x plus tan x plus c. Now this proof is not so difficult. We can do secant x dx equals to I integration. So now we can multiply secant x plus tan x in both numerator and denominator. Then the numerator will become secant square x plus secant x tan x, and denominator is secant x plus tan x. So dx. Now we can put secant x plus tan x as z. And we know that integration of secant x is secant x tan x. Sorry, not integration. Differentiation of secant x is secant x into tan x, and differentiation of tan x is secant square x. So if we differentiate both the side, we can get secant x tan x plus secant square x dx equals to dz. Now from these two terms we can take secant x common. So it will be secant x into secant x plus tan x. So which is the numerator of this integration. So therefore we can say that secant x into secant x plus tan x dx will be equals to dz. Hence we can write I is equals to dz by z, which is equals to log mod z plus c. Hence we can write log of mod secant x plus tan x plus c. So we prove that integration of secant x dx equals to log of mod secant x plus tan x plus c. Now we can also write this thing, that is log of mod tan pi by 4 plus x by 2 plus c. Let's see the proof of this part. Now as we know that secant x can be written as 1 by cos x, and again we can write cos x as sine of pi by 2 plus x. Now this sine pi by 2 plus x can be written as 2 sine pi by 4 plus x by 2 into cos pi by 4 plus x by 2. I applied the formula sine 2 theta, which is 2 sine theta cos theta. So here theta is actually pi by 4 plus x by 2. Now here we can take this 2 outside, so it will be 1 by 2, since 2 is in the denominator. Now we can multiply secant square pi by 4 plus x by 2 in both numerator and denominator. Now see, if I multiply secant square pi by 4 plus x by 2 in the numerator, it will be just like that. But when I multiply this in the denominator, so 1 cos pi by 4 plus x by 2 will be cancelled out with 1 sec pi by 4 plus x by 2. And the other sec pi by 4 plus x by 2 will come in the denominator of this sine and will make this one tan. So it will become tan pi by 4 plus x by 2. Now we can put tan pi by 4 plus x by 2 as z. Now if I do so, then the differentiation of these will be, first of all, tan's differentiation is secant square. So whatever is written here I will write this. So secant square pi by 4 plus x by 2. Now into differentiation of pi by 4 plus x by 2. Now differentiation of pi by 4 plus x by 2 will be 1 by 2. So it will come there. So we get half secant square pi by 4 plus x by 2 into dx equals to dz. I applied the chain rule here. Now the integration will become, now this half is outside this integration, we can put that half inside. So we can write half into secant square pi by 4 plus x by 2 dx by tan pi by 4 plus x by 2. So this thing will become dz. So we can write dz here. So dz by z. This is z. We know this is log of mod z plus c. Hence we can write log of mod tan pi by 4 plus x by 2 plus c. So we got the proof of the second result. Now the fourth one is integration of cosecant x dx is log mod cosecant x minus cot x plus c, or log of tan x by 2 plus c. Now this proof is also similar to the third proof. I must tell you that you should try this integral. Now let us see some of the examples. So first example is 1 plus tan square of 7 minus 2x by 2 by 2 tan 7 minus 2x by 2 dx. So here we can write the integral I as 1 by reciprocal of that. So if I do the reciprocal, so it will be 2 tan 7 minus 2x by 2 divided by 1 plus tan squared 7 minus 2x divided by 2. Now this is in the form of 2 tan theta by 1 plus tan squared theta. So which will become sine 2 theta. So if I do the sine 2 theta, so it will be double, the angle will be double. So therefore the angle will be 7 minus 2x. So 1 by sine 7 minus 2x, which is equals to cosecant 7 minus 2x dx integration. So this is the integration of the form integration of cosecant x dx. We know the formula of cosecant x dx, which is equals to log of cosecant x minus cot x mod. plus c. So we can write log of mod cosecant. So instead of writing x, I will write 7 minus 2x. So cosecant 7 minus 2x minus cot 7 minus 2x mod into, now the coefficient of x is minus 2. So this minus 2 will be divided. So minus 1 by 2 plus c. So why this is divided, that I have given in the first part of this substitution, integration by substitution part. So please see the video. So therefore it will be half minus half log cosecant of 7 minus 2x minus cot 7 minus 2x mod plus c. Now the next question is what is the integration of sine square minus cos square x, sine square x minus cos square x by sine x cos x dx. So this is suppose I, so we can write the integration I as sine square by sine x cos x. I am distributing the denominator, so minus cos square x by sine x cos x. Now here we can cancel out one sine x, so it will be sine by cos, which is tan x, minus, now it will be cos, one cos cancel out, so cos by sine, so it will become cot x dx. So integration of tan x minus integration of cot x, which is log of secant x minus log of sine x plus. Now the integration has one alternative method. So there it was given sine square x minus cos square x. Now we can take a minus common to write it as cos square x minus sine square x by sine x cos x. Now here we can multiply 2 in the numerator and 2 in the denominator. Now you can understand what I am trying to make it. Since it is cos square x minus sine square x, it will be cos 2x, and it is 2 sine x cos x, it will be sine 2x. So ultimately it will be minus 2 into integration of cos 2x by sine 2x dx, which is minus 2 into cot 2x dx. Now we know the formula of integration cot x. Integration of cot x is log of sine x mod. Now here it will be minus 2 came out, minus 2 here. So integration of cot 2x is log of mod sine 2x. Now the 2 is multiplied with 2 with x, so therefore it will be 1 by 2 multiplied with that whole integral. So it will be minus 2 log of sine 2x into 1 by 2 plus c. Now this 2 can be cancelled out. We can write minus log sine 2x plus c. So here we can see that there are two different answers. In the first part, in the first method, we have seen the answer is log of mod secant x minus log sine x plus c. And in the second method, the answer is minus log of mod sine 2x plus c. Now you must be thinking that what can be the correct answer. But here both the answers are correct. In fact, both the answers are same. Now we can write this minus log sine 2x as minus of log 2 sine x cos x mod plus c. Now we can write, since there is a multiplication inside the log, we can add them outside the log. That means minus log 2. Since there is a minus, so minus will also distribute. So it will be minus log 2 minus log mod sine x minus log mod cos x plus. Now this is a constant number, minus log 2. So we can add this minus log 2 with this constant and make it another new constant, that is c dash. And now this minus log cos x can be log of secant x. So this will be log of secant x minus log mod sine x plus. Now we can see this is the result of the first method. Here we have the result, log mod secant x minus log sine x plus. Now let's see the third question, that is integration of sine x by sine of x minus a dx. So what will be the integration of that? So we can write sine x as sine of x minus a plus a. Now we can apply the sign of x plus y formula, taking x minus a as one angle and a as another angle. So it will be sine of x minus a into cos a plus cos of x minus a into sine a. Cos of x minus a into sine a. Now we can distribute this denominator. So if I distribute this denominator with that term, sine of x minus a will be cancelled out. So only cos a will be there. So, and we also distributing the integration. So therefore it will be cos a into dx. So this dx will also distribute. Plus, now if we distribute with that, so cos x by cos of x minus a by sine of x minus a will be cot of x minus a. So it is integration of cot of x minus a, and this is sine a, which is a constant number. So this sine a will go outside the integration. So it will be sine a integration of cot x minus a dx. Now after the integration we will get this cos a is a constant number, so that means it is integration of dx. So x cos a plus sine a is outside. So now integration of cot of x minus a will be log mod sine of x minus a. So into sine a, because sine a is outside, plus. Now in the similar way we can find out this integral. This is the fourth integral, that is integration of dx by sine of x minus alpha into sine of x minus beta. Now here we can multiply and divide sine of alpha minus beta in both numerator and denominator. So this sine of alpha minus beta, which is a constant, can be outside of integration. So integration of sine of alpha minus beta by this. Now this alpha minus beta can be written as x minus beta minus x plus alpha. So here I am adding and subtracting x. Now I will apply sine theta plus 5. In fact we can take this minus common then. So if we take that minus common, so it will be sine of x minus beta minus of x minus alpha. So now we can see that x minus alpha, x minus beta is in there in the denominator. So we are getting some form of x minus alpha and x minus beta in the numerator also. Now we can see this is of the form of sine theta minus 5. So taking the whole thing as theta and this one as 5, we can apply the formula of sine theta minus 5, which is sine of x minus beta into cos x minus alpha minus cos x minus beta into sine x minus alpha dx. So we can write 1 by sine alpha minus beta into integration of this thing divided by sine x minus alpha into sine x minus beta dx. Now we can distribute the denominator. Now if I distribute the denominator, here the sine functions will be cancelled out. So here we can see sine of x minus beta is there, and here also we can see sine of x minus beta is there. So we can cancel this and we will get cos x minus alpha by sine x minus alpha, which is cot x minus alpha, minus. Similarly here also we will cancel out x minus alpha of sine. So this will be cancelled out. It will be cot of x minus beta. Now we can distribute the integral and we can find out the integration. Result of the integration will be 1 by sine alpha minus beta into, now cot, the integration of cot is log of mod sine. So it will be log of mod x minus alpha. Now with x, what is the coefficient? The coefficient is 1. So by 1, so no need to write. So it will be log of mod sine x minus alpha minus log of mod sine x minus beta plus. We can do this one more simplification. It is correct up to this, no need to do after that, but if you want to do this kind of simplification you can do. That is, since there is a minus, so it will be division inside the log. So log of sine x minus alpha by sine x minus beta plus. Now let's find out the integration of the fifth one, that is the integration of dx by root over of 1 minus sine 2x. Now we know that 1 means sine square x plus cos square x and sine 2x means 2 sine x cos x. Now it is inside the root over. Now this is actually of the form of a square plus b square minus 2ab. We can apply the formula. It will be a minus b whole square. So root over of sine x minus cos x whole square. Now if you do this, if we do root over of x square, it will give mod x. So we can write root over of sine x minus cos x whole square will be mod of sine x minus cos x. Now we know that if we remove mod, there will be a plus minus outside. So we can write plus minus of sine x minus cos x. This plus minus will go outside of the integration. So it will be plus minus dx by root over dx by sine x minus cos x. Now here what I have done, here I have to simplify this thing. So here I will multiply and divide root 2. So if I multiply and divide root 2, that is a kind of trick here. So what we will get, so root 2 if I multiply, so root 2 will be divided with both the term. So it will be 1 by root 2 sine x minus 1 by root 2 cos x. Now we can apply the value. We know that sine 45 degree is root 2. We can write cos 45 degree also 1 by root 2. So we can write sine x into sine pi by 4 minus cos x into cos pi by 4. We can write cos pi by 4 also here, no problem. Then there will be another result. Now this root 2 will go outside, so it will be plus minus 1 by root 2 sine x sine pi by 4 minus cos x cos pi by 4. Now here one thing we can do, we can actually with this form there is no formula, but if it is cos x cos pi by 4 in that side, then we can apply the formula. So for that we need to take out this minus. Now if I take common minus, so it will go outside and will make it minus plus. But plus minus minus plus, there is no difference between plus minus and minus plus. So let it be plus minus only. So 1 by root 2 dx by, this will become now cos pi by 4 plus x. Now 1 by cos pi by 4 plus x will become secant pi by 4 plus x dx. Now we can apply the formula. So it will be plus minus 1 by root 2 log mod secant pi by 4 plus x plus tan pi by 4 plus x plus c. Now this is the second phase of today's video, that is how to integrate this kind of integrals, that is integration of sine to the power mx into cos to the power nx dx. Now there are some rule. Rule number 1, if m is odd and n is even. So here if m is odd and n is even, we can write this integrand, that is sine to the power mx into cos to the power nx, as sine to the power m minus 1x into cos to the power nx into sine x. Now since m is odd, then m minus 1 will be even. So therefore we can write sine square x whole to the power m minus 1 by 2. So here m minus 1 by 2 will be an integer. Now we can write this sine square x as 1 minus cos square x. So therefore in the integration we can write, it will be, the integration will be 1 minus cos square x whole to the power m minus 1 by 2 into cos to the power nx into sin x dx. Now simply I will put cos x equals to z. Now if I put cos x equals to z, it will be minus sin x dx equals to dz. So minus I have to take here and minus sin x. There will be a minus here. So minus sin x dx will become dz, and all the cos will be converted to z. So therefore it will be 1 minus z square whole to the power m minus 1 by 2 into z to the power n. Now if m is even and n is odd, So similarly it will be like number 1. So here I have to simplify in such a way that we have to put sine x equals to z. We can see this example. Here it is given that sine to the power 3 means sine cube x into cos to the power 4x dx. So here we can see that m is odd and n is even. Okay, so in that case we can write this thing as sine square x into cos to the power 4x into sine x dx. Now simply I will make this sine square x as 1 minus cos square x into cos to the power 4x into sine x dx. Now everything is this portion is in terms of cos and this is sine, only one sine is there. Now we can put cos x as z, so therefore it will be minus sine x dx equals to dz. So that means we need to adjust the minus. Now to adjust the minus we need to multiply minus here and I will adjust the minus here. So it will be minus integration of, now this is multiplied cos to the power 4x minus cos to the power 6x into minus sine x dx. Now this minus sine x dx will become dz and this will become z to the power 4 minus z to the power 6. Now we can apply the formula. Z to the power 4 will be z to the power 5 by 5 and z to the power 6 will be z to the power 7 by 7. So therefore it will be so now since z is cos x, so again replace back. So let me write this thing first. So 1 by 7 cos to the power 7x minus 1 by 5 cos to the power 5x plus. So here the first and the second rule is same, similar kind of thing. So when m is even and n is odd, then you have to put sine x equals to z, and when m is odd and n is even, in that case you have to put cos x equals to z. Now let's see the third rule, that is when both are odd, then anything we can take, either sine x as z or cos x as z. So let's see the example. So here we have this example, integration of sine to the power 5x into cos to the power 7x dx. Now we can write this cos to the power 7x as cos to the power 6x into cos x. So here I am planning to take sine x as z. So if I take sine x as z, so I need to take a cos x out. So only one cos x will be there and everything will be in terms of sine. So now cos to the power 6x can be written as cos square whole cube. Now this cos square will be 1 minus sine square x whole cube. Now we can see everything is in terms of sine, only one cos. So take sine x equals to z. Sine x equals to z means cos x dx will be dz. So therefore this cos x dx will be dz and this will be z to the power 5 into 1 minus z square whole cube, so dz. Now we can apply the formula of a minus b whole cube. So this is the formula of a minus b whole cube. I applied, so z to the power 5 into this. We can distribute this, we can find out the integration of this term, which is very simple. Then after finding out, we can replace the value of z. The value of z is sine x. So since we know this will be z to the power 6 by 6, so we can write 1 by 6 sine to the power 6x. This will be 3 by 8 z to the power 8, so it will be 3 by 8 sine to the power 8 x. Now since we know that it is z to the power 10 by 10, so it will be 3 by 10 into sine to the power 10x. Now this will be 1 by 12 z to the power 12 by 1 by 12, so it will be 1 by 12 sine to the power 12x plus. Now the question is, when both are even, then what to do? When both are even, then we need to apply the trigonometric identities. Again trigonometry. Okay, so let's see the example. Integration of sine square x cos to the power 4x. Both are even dx. So let's see. Here I have to apply the trigonometric identities. So there are many identities. Let's see what kind of identity we can use. So I'm planning to make it sine square x into cos square x into cos square x, because we can apply sine x cos x, 2 sine x cos x as z, but we can see 2 sine square x is there and 2 sin x is there and 2 cos x is there, and another 2 cos x I have written here. 2 cos x means I am trying to say 2 factors of sin x. So that will be 1 by 4 into 4 sin square x into cos square x. So it will be 2 sin x cos x whole square. Now these cos square x can be written as 1 plus cos 2x by 2, which is another trigonometric identity. So from the formula of cos 2x we can derive this. Now this is the formula of sin 2x. We can definitely write this thing as sine square 2x, and this 2 will go outside, so it will make it 1 by 8, and this will be into 1 plus cos 2x. Now we can multiply and distribute the integral. So it will be 1 by 8 sine square 2x dx plus 1 by 8 sine square 2x cos 2x dx. So there are two integrations. One is I1, let us assume this one is I1 and this one is I2. Now let me integrate the first integral, that is I1, the integration of sine square 2x dx. So we can apply the formula. This is half 1 minus cos 4x dx. This is again another form of cos 2x. So this will be x by 2 minus cos 4x integration is sin 4x by 4. So it will be x by 2 1 by 8 sin 4x plus c1. Now the next one is I2, integration of sin square 2x cos 2x. Integration of sin square 2x cos 2x. We can apply the substitution method. Sin 2x we can assume that z 2 cos 2x dx will be dz. So we need to adjust 2. So 1 by 2 2 cos 2x dx here. So 2 cos 2x dx will be dz and sin square 2x will be z square. So it will be 1 by 2 z square dx. So it will be z cube by 3. So it will be 1 by 6 z cube plus c2, or 1 by 6 sin cube 2x plus c2. Now we can add since the integral is 1 by 8 I1 plus 1 by 8 I2, we can add both the values. This is I1 and this one is I2. We can just put the values of I1 and I2 and we can come to this result. So it will be x by 16 minus 1 by 64 sin to the power 4x plus 1 by 48 sin cube 2x plus. Now lastly we can say that if m and n are rational numbers and m plus n minus 2 by 2 is a negative number, then we can put cot x as z or tan x as z, whichever is required. We can see this fourth and final example of today's video, that is integration of dx by sin x into cos cubix. Now here we can see that m is definitely minus 1 and n is minus 3. Now if I add m plus n minus 2, if I find out this value, this is coming negative value. So therefore we need to put either cot x as z or tan x as z. So what we can do, let's see. This is sin x into cos cubix. Now here again we can multiply second whole to the power 4x, second to the power 4x in numerator and denominator. So if I multiply second to the power 4x in denominator, cos cube and 3 power, all these 3 powers will be cancelled out. Now let us see this example. This is the fourth and final example of today's video. That is dx by dx by sin x into cos cubix dx. So what will be the integration of this thing? So in that case we can see here m is minus 1 and n is minus 3. And if we find out this value, it is coming negative. So that means either we have to put cot x as z or tan x as z. Now let's see, if we multiply second to the power 4x in both numerator and denominator, it will be second to the power 4x by tan x dx. Now this second to the power 4x can be written as second square x into second square x, and this is the formula of secant square x, that is 1 plus tan square x. So we can write 1 plus tan square x by tan x into secant square x dx. Now we can put tan x as z. So if I put tan x as z, we can write secant square x dx equals to dz. Then we can write integration this I as 1 plus z square by z into dz, as it was 1 plus tan square by tan x. 1 plus tan square x by tan x. Now if we distribute the denominator, it will be integration of 1 by z plus z of dz. So this is equals to log mod z plus z square by 2 plus c. So we can write log of mod tan x plus tan square x by 2 plus c. That's all for today. I hope you can understand integration by substitution. In my next video, I will talk about some more standard integrals. Thank you.